The other type of polynomial division is long division. Now, just by hearing the name, the reason that most people don't really like this is because it's kind of a longer process. But the good thing about long division is that it always works. Remember when we talked about synthetic division, it only worked with the linear divisor. Okay, so in long division, it works no matter what the divisor is. So for this example that they show here, it actually is x squared minus 1, which this would not be able to be done with synthetic division because that's a squared term. It's no longer linear. So long division is good because it will work no matter what. So in polynomial long division, you're going to start the same way you did before, where we were putting in zeros if we were missing any variable. I'm going to do that for the divisor and the dividend. So if you look at this example they gave us, notice that they're including a 0 for the x here because I was missing that term, and I was missing the term in the dividend. So this is like the old school long division that you used to do, where you put the number you're dividing by on the outside. Then under the division symbol, you're going to put the dividend, whatever you have in the numerator, which you're dividing into. And if you think back to regular long division, let's say we have 429 divided by 3. Remember, whenever we were in elementary school, we would say, okay, well, can 3 go into 4? We would say, yes, it goes in there one time, because 1 times 3 is 3. Then we'd say, okay, let's subtract that. 4 minus 3 is 1. Bring down the 2. Can 3 go into 12? Yes, it goes into there 4 times. And 4 times 3 is 12. Subtract that, we get 0. We're going to bring down the 9. Can 3 go into 9? Yes, it can go in 3 times. 3 times 3 is 9. Subtract 0. So there's no remainder. Okay, so we're going to do this very similar process. Okay, so they started off here. They've written their dividend in their divisor. Then they start off and they say, okay, can x squared go into 3x cubed? It can, because if I multiply 3x by x squared, I would get 3x cubed. All right, so the difference here is that when we were in elementary school, we multiplied one term by the outside. Now we're going to multiply, and it's really like a distribution. We're going to take that 3x to every term that's on the outside. That's where they're getting this 3x cubed, 0x squared, and that negative 3x, because they distributed the 3x. All right, then I'm going to subtract everything. So when I subtract, those first terms cancel. I subtract to get a negative 2x squared. I subtract to get a positive 3x, and then I bring down that 6. Then we're going to start the whole process over. And we say, okay, what about x squared? Can x squared go into a negative 2x squared? Yes, it can. I can multiply by a negative 2. So they did that. They took negative 2 and they multiplied by everything, right? So the process here, same as we were doing whenever we were younger in elementary school. However, it's going to change a little bit because we're distributing the value to everything in front, okay? But the same idea where we're going to multiply, subtract going down, bring down the next term. Okay, so I'm going to do that process until I find that there's nothing left. The reason I know there's nothing left is because x squared cannot go into 3x. Another way that I know that I'm done is because there is nothing left to bring down. Okay, remember in elementary school when there was nothing left to bring down, then we could put like a decimal and we could start adding things. But that doesn't exist in polynomial division. Okay, so when there's nothing left to bring down, or you notice x squared I can't multiply anything by x squared to get just a 3x, There's no way to go backwards like that. Then we've got our answer. Very similar to synthetic division, I'm going to take the remainder, whatever's left in the end, that's going to go over that divisor, whatever I was dividing by, and then what's on top is going to be what we call our quotient, or our answer that will get added to that remainder. Okay, so we're going to look at an example. We're going to go all the way through the steps and see if we can figure this out. Okay, so I'm actually going to come over here on the side because I think I'm going to probably write a little bit too big down here. So let's look at an example. Let's say that we have 3x cubed plus 4x plus 18, and I want to divide it by x squared minus 3x plus 2. Okay, so the first thing that I'm going to do is I'm going to write my equation out, or excuse me, my division out. So I'm going to put my x squared minus 3x plus 2 on the outside, and then I'm going to put my 3x cubed. I'm going to need a 0x squared because I'm missing the squared term, plus my 4x plus my 18. All right, now that it's set up, I'm going to ask myself, okay, well, what do I need to multiply x squared by to get 3x cubed? Well, I'm going to need a 3x. So I'm going to take that 3x now and I'm going to distribute. So I'm going to multiply that 3x by x squared, I get 3x cubed. Then I'm going to take that 3x and I'm going to multiply it by my negative 3x, and I get negative 9x squared. Then I'm going to take my 3x and I'm going to multiply it by 2. So I'm going to get 6x. All right. Now that I've gotten that written, I'm going to subtract each of these values. Okay. When I go to subtract, these two terms will cancel. I'm going to have 0 minus a negative 9x squared, which is going to give me 9x squared. 4 minus 6x is going to give me negative 2x. And then I would bring down my next term. Right? So we start the whole process over. I say now, what do I need to multiply x squared to get 9x squared? So I'm going to multiply by a 9. So now I take that 9 and I need to multiply by everything. So I'm going to take 9 times x squared gives me that 9x squared. 9 times negative 3x gives me a negative 27x. 9 times 2 is going to give me an 18. And then I'm going to subtract. Whenever I subtract, I'm going to cancel off these first two. Negative 2 minus a negative 27 is going to give me 25x. 18 minus 18 gives me 0 there. So I don't really need to include that. I can just cross that off. So I still do have a remainder, right? And the reason I know it's a remainder, there's nothing left to bring down here, okay? I can also say, well, there's nothing that I can multiply x squared to give me 25, just x, right? So now I'm going to write my answer. Remember, the way that I'm going to write my answer is I'm going to take my remainder, put it over what I was dividing by, that divisor, and then I'm going to add that to my quotient above, so that 3x plus 9. So that would be my entire solution. Okay, so I'll make that a little bit smaller, move it over here, and let me do another example for us real quick. Okay, so let's try another one. One more, make sure we kind of got what's going on here. So let's say that we have 3x cubed minus 5x squared plus 7. And I'm going to divide that by x squared minus 1. Right, so for this one, the first thing that I'm going to do is I'm going to write out my equation, or excuse me, my division here. Sorry, I keep saying that. So I'm going to have x squared. I'm going to need a plus a 0x. minus 1. I need that 0x because I was missing it. So now I'm going to have 3x cubed minus 5x squared plus 0x plus 7. Remember, I need to include those zeros if I'm missing something. All right, so let's start it off here. I start off and I say, okay, how can x squared become 3x cubed? I need a 3x. So now I'm going to multiply. 3x times x squared gives me 3x squared. Or excuse me, cubed. 3x times 0x gives me 0x squared. I'm going to put the 0 because I need to hold the place, just like we put the zeros before. 3x times negative 1 gives me a negative 3x. All right, so I'm going to now subtract all of those values. When I subtract, that first one's going to cancel. If the first one does not cancel, I've done something wrong. Okay, so that should always happen. So I'm going to have a negative 5x squared minus 0, still going to give me negative 5x squared. 0 minus a negative 3, so it's going to become a positive 3x. And then I'm going to bring down the 7. All right, so now we're going to start over. I want x squared to be negative 5x squared, so I'm going to say negative 5. I'm going to now multiply. Negative 5 times x squared gives me negative 5x squared. Negative 5 times 0x gives me 0x. Negative 5 times negative 1 gives me 5. So I'm going to subtract those. That's going to cancel off those first term. 3 minus 0, well, that's just still 3x. 7 minus 5 plus 2. All right, so now we see, okay, well, we've got a remainder. I know that it's a remainder because there's no way that x squared can go into 3x. And also, there's nothing here for me to bring down. I'm done. There's nothing left. All right, so now I'm going to go write my answer. Remember, the way I'm going to write my answer is I'm going to take that remainder, 3x plus 2, put it over what I was dividing by, x squared minus 1. Then I'm going to add back on my quotient, so 3x minus 5. Right? And that's how I'm going to do long division. Remember, although it's a little bit more tedious, I have to be really careful with that subtraction as you're going through. A lot of people kind of mess up the signs. So although it's a little bit longer of a process, the good thing about it is that it will always work, no matter what the divisor is, whether it's linear or not.